Okay, welcome back. Topic 4, displays. 4.2, display design principles. And this is part 2 of the 13 principles of human-centered display design. So 4.2.1 included the first 7 principles, the perceptual and mental model principles. Today, what's this about? Hello. Today, look at the 4.2.2 side. So we're going to do attention-based principles and memory principles. Okay. All right. So principle number 8, because the previous 7 were covered in 4.2.1, is about recognizing the limitations in attention and the fact that attention is costly to spend. And so we want to minimize the number of things we have to process and decisions that have to be made to get to our target here. So if you describe the search for information in our display as having several steps that we have to get through, we'd call this a higher information access cost. So think of it like, you know, the number of folders I need to click, or the number of buttons, or maybe the number of places I have to look, you know, in order to get to, you know, the answer I need. So as a general principle, we want to, you know, minimize that cost. All right. This is an example of something that I studied in grad school, which is looking at some classic, some well-studied aviation accidents, and looking at how those related to some of the technology, some of the system factors involved. This is the flight management system is basically the computer inside most modern aircraft. And this thing that looks like a glorified calculator is called the control display unit, the CDU. The CDU for the FMS. Okay. And you'll note it's got sort of an archaic look to it. This was, you know, the technology is a couple decades old now, and I'm not really sure if current days, if it still looks this basic. But imagine that there's a standard you want to continue to uphold over several years of training, where I know where certain pieces of information are. I have to go to potentially, you know, the 7th display page in this unit. So we're maintaining it's going to be consistent over the years. And so it's interesting that some, you know, some key pieces of information may take 5, 6, 7 button presses, which is especially costly at some times, you know, during flight, for example, like if I were landing. So, you know, some of these accidents involve things like, well, I had to get to the 7th page to find out that my current routing was taking me to, you know, the wrong waypoint because I entered it the wrong way. But it was so buried in here, I didn't see that until it was too late. And then, you know, in the case of the crash in Cali, Colombia in 1995, you know, they were going to the wrong waypoint, crashed into the jungle there. All right, so to think about, especially under stress, time pressure, you know, we need to get to the information we need with the minimal amount of cost. And a good example of a good application of this, you know, are the voice activated commands in most current, you know, in current smartphones. So, you know, this might be Hi Siri also if you're an Apple user. Okay. The 9th principle. Now this one, get ready for it. It's my favorite. I like to ask quiz exam questions on these. The proximity compatibility principle. This is one of my favorites also because I talk about it in several of my classes, because it's such a basic principle, but it solves so many issues in interface and display design. Okay, so it starts with this. We have 2 concepts to define here. the display proximity. And so this relates to if I have two different display elements, how similar they look and how much they look like they go together. So there's a lot of ways, the way that humans process visually a scene, what makes things look like they go together, if they have similar shape or size or other stylistic, properties. This makes people sort of naturally associate them. And so that's what we call the display proximity. And then we have the processing proximity, which is these two displays. How often for the tasks I'm trying to do I need to process the two of them together? How often are they used in similar cognitive tasks? All right, so once we understand that about if we've got two display elements, we can define their display proximity, we can define their processing proximity. Then you say, well, if these two displays are frequently used together, if they're related to common tasks, if they are commonly needed to be compared, well, if they're used together, they have high processing proximity, so make them have high display proximity. Or in other words, if I'm going to use these two together, make them look like they go together, so don't make the human, have to process an additional step to, to associate them. Take advantage of the way that people, basically how their attention works, in terms of grouping things, for example. All right, now this is only half of it, and this is the part where I'd like to get people, or just be ready for it on exams, etc. It's this other half of this principle, which is if things are not used together at all, and they only could hurt the system by maybe being confused as going together, then the system is better off if they have low processing proximity, they have nothing to do with each other for any task, then make them look like they don't go together. Spatially separate them, make them look different colors, different sizes, different styles. And then this way, there's no temptation for those to be associated in a confusing way, display elements. All right. So I've got an example here. The common look to a car dashboard. Now, what I see here are some very high display proximity. We have several displays that are shaped the same way, move the same way, are also spatially proximal. They have the same sort of hue look to them. So there's a lot of similarities that make me think, before I even know what these four gauges are, they're probably related somehow. Okay. And indeed they are. I mean, maybe you wouldn't say that gas is so much related to, well, I don't know, maybe there are relationships among these that you want to preserve. And so then those are the two dimensions that this is the question. Yes, they look similar in a lot of ways. They have high display proximity. Do they indeed have high processing proximity? And what if I say, well, each of these display elements is important, but really the most important focus of our attention while we're driving is the roadway itself. And so if every time I'm looking at the roadway and I have to look down into the dashboard and look at, all right, which of these circular things is the specific data I want, maybe that's, that processing proximity is very high, but maybe we don't have the display proximity we need. And I'm not just talking about how close they are in space, it's how close they are in how likely you could be to sort of confuse them, I think is a good way to put it in this case. So how similar they look, which includes how close together they are, but also if they are, the same shape and size, in addition to being near each other, that makes them that much more proximal in terms of their display proximity. So this is where, advanced displays like heads-up displays, maybe with this sort of a, configuration, now our main focus of the roadway and the secondary display we need of, speedometer or, the gas level. Now we're making them, since they have such high processing proximity, maybe this is a way to increase the display proximity. So I'm better, associating with that, or I'm better applying that proximity compatibility principle. All right. So again, love that. I love asking about that one. So if you are confused about it, again, drill on it, come and meet me in office hours. All right. The 10th principle, also another attention-based one, is we call the principle of multiple resources. Okay. So this is the first time I'm introducing this theory, and I highlight it because we'll talk at more length, I think, in topic 8 on that theory, but it's a big thing that drives a lot of the research I do. And it basically relates to this idea that we have different structures, neural structures in our brain that are more or less focused on processing information in a certain way. So one example are the different senses. And we know this from neural imaging that, if people are processing a touch sensation, they'll see more activity in this region. And then, our other senses are processed in different parts of the brain. There are also things like working memory, like spatial reasoning, that also have their own, at least theoretical structures in the brain. Okay, at least theoretical, reserved resources, so to speak. So what this theory says is, well, we know those resources are limited, but if we distribute the task across these resources, these sensory resources, these working memory resources, these response motor resources, that's also part of it. If we can spread across those different channels, then we can have a more efficient information processing system. So the way we would apply this then is to say, well, let's look at the environment in which we're introducing this new message. We're putting a new display in a car. And if we say, well, what's going on with people while they're driving in that environment, so we know what's already in high demand and what might be relatively available. Okay, so here's my example. Yes, again, we're going to talk topic 8 more on this thing. But yeah, I'm driving along the road here. I got to be paying attention to the roadway, most important. And the question is, what's an effective way to convey this new, map, GPS, advanced sort of app system, let's say. All right. So I'm already in, we have an environment that's visually demanding and highly in demand of my spatial reasoning. Where am I relative to other vehicles, relative to my destination? So those are resources that are already kind of engaged in something. That leaves some alternative resources relatively available, right? So our sense of hearing, and then maybe some non-spatial, more verbal sorts of processing, right? So this is why it's okay for me to drive very safely and listen to the radio, because these are engaging different sensory channels for the most part and different working memory functions, more spatial processing and more verbal processing. So, and we'll talk more about that, when we get to topic 8. But this gives us a display design principle that we can think about. So if we think about the context into which we're designing, which resources are already in some degree of demand, what's relatively available in terms of the human information processing resources, they're multiple resources, and redistribute, the demand across them. All right. All right. Home stretch here. So the last 3, the last 3 were the attention-based principles. And then the final 3 here are memory principles. So, how human memory works. We're going to design our displays to accommodate the fact that people can't remember which side of the car their gas tank is on. And I still have this problem with my current vehicle that I've been driving for 5 years or whatever, right? So, but you know, while it's funny to say, well, I still can't remember this, and maybe you knew this, maybe I just told you, like, I'm about to tell you an amazing revelation, but this arrow here, fuel door, generally any current vehicle, I've never seen one that doesn't have this anyway. There's a little arrow near the gas gauge, and it gives you an indication of where, on which side of the car is the fuel door. Very important for when you go and take a rental car somewhere. Like tomorrow morning, I'll be in a rental car and I'll have to figure out how to fill up with gas, and be nice to know, without having to get out like an idiot. So, but in any case, this is an example. Even if I, am driving my current vehicle, it's, some of these familiar, is it this or is it not this sorts of things to remember, can make it surprisingly difficult for these coin flip sorts of things. Is it on the left or the right? Well, it's on the right. Or wait, do I always think it's on the right and it's not? And it's, you know what I mean? So anyway, this concept of knowledge in the world, rather than putting the burden on the human to hold that knowledge in their head. Why make me remember that my gas tank is on the right if it costs very little to put a little indicator on my gas gauge, which I'm going to be looking at the gas gauge if I'm thinking about gas. So it gives me that indication right there very easily without cluttering, too much in that space. So, and that is the high end, right? So, there's always this trade-off. We can keep adding things into the world so the human doesn't have to remember anything, or fewer things. But then we clutter that space. We make it harder to find the key information we need when there's more, noise. All right, principle of predictive aiding. This is the 12th principle, I suppose. So if you think about how you would, if you're walking down the street and you were able to pause the universe and in your current state be able to predict, all right, in 7 seconds, here is where I'm going to be and here's what my world is going to look like. That would be amazingly difficult for us to do with our current, capacity. Now we could do something. We could think, all right, I'm walking about this fast. I could estimate. I could kind of think about, I could be predicting numbers based on, other rates that I knew I had run or walked in the past. But I'd be doing an immense number of calculations in a very short amount of time to have a reasonable prediction. And what this illustrates is humans are just not very good at that. So we can't predict, much more than, and I don't even want to say a few seconds, but just a very short amount of time in our near future. We're just not very good at, we're not very accurate at predicting what's going to happen or where we're going to be. Okay. But machines are excellent at it, right? And so what this principle says is essentially recognize that humans have a big problem with this. So for example, if I'm looking at a map and I need to know, okay, coming up here, you got to go left, right, left, really quick, driving through Houston, for example, you got to take this exit and then you got to take exit B. And then on the left ramp, it's going to happen to me. I'm driving to the airport tomorrow morning. I'm probably going to miss something. I always do. But part of that is, okay, can I predict far enough ahead? Can I preload my sequence of activities, so that I'm able to, execute them in short order? The answer is no. And a lot of it has to do with my limitations in working memory space. I just don't have the computational space to think all that far ahead for the number of steps I need to do. So again, what this is saying is let's use the intelligence of, automation to predict things for humans. So especially tell me what's happening in the near future. Okay. So it's a good way to summarize this whole principle is tell humans what's happening in the near future because it's really, really valuable, more so than the human might expect. Okay. Tell me, here's your next turn. tell me how long until my next thing. Give me some foreshadowing information as much as I can. This is an example right here of an aircraft with a certain heading, and I'm changing the flaps and slats and the airspeed and the attitude. Where can I expect to be in 2 minutes in terms of where I am in relation to some mountaintops or something like that? Some things that we have to look out for. So this gives us a predictive sort of path here, right? And again, the computational power of the automation behind these displays can handle that much better than the human brain computer. All right, number 13. This is it, the last of the 13 design principles, and it would be it'll be familiar. So the idea of consistency. Old habits die hard, right? So if people are doing something a certain way, especially when stuff breaks down, like when there's a moment of, I'm driving my car and something unusual happened and I have to not crash, for example. It's especially important to have consistent, reliable sorts of mappings between your information sources and what you need in that moment. So especially when things break down, it's hard when this is usually where I always go, and it's not there, right? So the example, the anecdote I like to tie in here is pretty dated now, but there was a period of time when actually when I was an engineering student, undergrad, there was Microsoft Word, Microsoft Excel, Microsoft PowerPoint, but they were all very different programs. They did not have this similar look and feel and integrated sort of aspects to it. And so I learned each of those, in each of my engineering classes. And then everything changed, and they made a big effort to essentially standardize the look. And so even though that these programs have slightly different functions, they have different functions, but where they have similarities, they made those similarly accessible. So you didn't have to think, all right, how do I get to insert a text box in Microsoft Word versus Excel? It's a very, very common, consistent sort of search to get to that. So I remember this both from the concept of, well, when they transitioned to this, there was a huge, like the community of, I guess, engineers and Microsoft product users, were, he changed everything. I used to be able to go to file print, and now where's the print button? I don't know if that means anything to any of you that I remember that. So they broke the consistency. It used to be this way and people were very familiar with it. They disrupted that. It was costly, but once people got accustomed to the new system, now the similarity among the different programs makes working between them a lot easier, a lot more effective. Yeah, and here's another one that I'm likely to deal with my rental car tomorrow. It's hey, where's the windshield wipers when the rain starts coming down real hard and you're in a rental car at night? And on my car it's here, but on this rental car it's over here. And where's the gas tank unlock at 3:30 in the morning? I tell you what, I've had some times looking for that, in an unfamiliar rental car. But just imagine then again, how important it is if people are moving among different contexts. So if you drive in multiple different cars, when you have that moment where there's a near accident, and you need things to be as naturally and quickly interpretable as possible. And if things are not where your instincts want them to be in terms of the configuration, of where you would look for information, then that can be really disruptive. So, thinking of moving car to car, and if that ever disrupts you, and if you've ever been in like a near accident in somebody else's car that you were driving, or, and just to think, and here are the differences here. And a lot of it is going to be, well, whatever you're most familiar and comfortable with, there's that split second where that's the mindset that your brain's going to be working with. So being consistent is good on your on your instantaneous working memory. All right, and that wraps it up. So those are these 13 principles. You will use those in your homework for the week. All right.